Question number 31. X is an organic compound containing the elements carbon, hydrogen, and oxygen only. The table shows the observations made from 3 chemical tests carried out on X. So it reacts with an effervescence is formed. That means either OH or acid is present. It reacts with sodium carbonate. That means, and it gives effervescence. That means acid is present. And it reacts with hot acidified dichromate ion and remains orange. That means it is a 3-degree alcohol. So in this first one, we can see there is a hydrogen here, and this part over here is a 2-degree alcohol. So this is wrong. In this second one, there is no COOH, and the same thing is for this. There is also no COOH. In this one, there is a COOH, and also this one, this is a CH3, this thing is a CH3, and this is also CH3. So it is a 3-degree alcohol, and answer should be D. How many moles of oxygen gas are needed for the complete combustion of 1 mole of CH3COH? So CH3COH is C4H10O, and it reacts with O2 to form carbon dioxide and H2O. So if you balance it, 5 hydrogen there, then we can see 4 carbon. Since it is 1 mole, you can't change it, and so oxygen should be 1, 6, 13, 8. Okay, so it should be 6 because there is 1. There is total 13 here. There is 12 and 1 over here. So 6 O2. So we can see it's 6 moles. So answer should be A. For question 33, in which pair will each compound give a different visible result with alkaline I2? For option A, it is CH3, CH2, OH. Let me actually draw it like the displayed formula. CH3COH. So this is a 1-degree alcohol, and this one is CH3. So this one gives a yellow PPT with only one alkyl group, the ROH. So it is asking for different visible results for both of the compounds in each option with I2. So I2 gives yellow PPT when there is this group, or when there is a CH3CH CH3CHOH group. So these are the 2 times it will give yellow PPT. And in the first option, you can see one structure there, and this will give yellow PPT, and also this will give a yellow PPT. So that's wrong. In this option, this will give a yellow PPT. This will also give a yellow, because this group is what you have to look at, CH3CO, as I've mentioned here. So that is wrong. In this one also, there is okay, so in this one, none of them will give yellow PPT because they do not have the CH3CO. And also the other thing is, they did a different result. So both are giving same result. Even though they are not giving a positive result with iodine, they are giving the same result of no positive result. And in option D, let's check. This should be your possible answer, but yes, it does have CH3CH2OH, so it matches the first condition. And then the second one also has an alkyl group with a COH. So that should be your answer. Okay, there is actually, I did one mistake. So here, the thing is, there is no alcohol. There is a CH3. Both are going to give a positive result. Actually, I missed this. There is an alkyl group, and there is an alkyl group with ACO. So yes, that should be D. Question 34. Which reagent gives a positive result with propanone, So propanone is something that cannot be oxidized, can be oxidized. And let's draw the structure of propanone first, and CH3 and H3C. So it cannot be oxidized, so but it cannot be oxidized, but it does react, because this, if we consider this to be an R group, it has a CH3CO group, as in the previous question we were talking that is when it will give a positive result with iodine. So, and that is R, if we consider this to be R, so it has this group, so it will react with alkaline iodine, and it won't react with this other three reagents because it cannot be oxidized, as I've just told, because ketones cannot be oxidized. Question number 35. Esters can be hydrolyzed with an aqueous alkali or an aqueous acid to form two products. The table compares the two methods. Which row is correct? Aqueous alkali, aqueous acid. Complete conversion. Okay, aqueous alkali. So the esters can be hydrolyzed with an aqueous alkali or an aqueous. Alright. So first up, with acid, an equilibrium mixture will be formed. This is again the theoretical knowledge. So it will form an equilibrium mixture with an organic acid and an alcohol. The organic acid will form the ion form of the acid, and which is R, this thing, RCO2 minus H. So this can form, and so answer will be amongst A and C. And here it will be a complete conversion to a salt and alcohol, because with alkali there will be no equilibrium or no ion formation. It will be a direct salt and alkali, so option should be C. Structural isomerism only should be considered, only structural isomerism. How many compounds with molecular C5 are primary, which is 1 degree? So let's draw all of them that I can see of. So C5H11Br, the first one. I will not be drawing the hydrogens because you people already know there will be hydrogens. That is one structure. The other structure that I would draw is this one, right? This is the other structure. So 1, 2. Number 3 should be this is 1. Okay, now we can draw 2 branches, and it can be something like this. And the final structure that I can think of from this is moving. So one alkyl group we have provided here. If you provide one there in this position, then there should be the other structure. Yeah, I guess these are all 4 I can think about, honestly. Yeah, these are the all 4, so it's 4. These questions are good actually. Question 37. Compound Z is formed by the reaction scheme shown. So CH3CH2Br is warmed with KCN in ethanol, and it will form a nitrile, right? I'm drawing only the structures here again. And then it is refluxed with HCl, and finally it will form an acid, right? So it should be, option should be D. And question number 38 now. Hydroxyethanol HOCH2CHO is heated under reflux with an excess of acidified K2Cr2O7 until no further oxidation takes place. What is the skeletal formula of the organic product? So the 1 minute. So first let's actually draw the structure of this. So let's draw the structure of this. This is the structure, and this is the structure of the hydroxyethanol, and it is heated under reflux. So the acid cannot further oxidize, but the OH group can oxidizes. And first let's check which have 2 carbons. This one has 3 carbons, so this is wrong. This has 2 carbon, and here the oxidation did not occur, so that is wrong. And here, okay, so it does not become aldehyde, it becomes an alcohol with K2Cr2O7. Sorry, it becomes an acid, it does not become an aldehyde. So it's 2 carbon, and that is correct. It should be B. 39, the formula shows the repeat unit of an alcohol. So first let's it should be somewhat like this. If we draw CH3, we have drawn the CH3, and with this carbon and this carbon will form the double bond, again an H, and the rest of the thing CH2 CH3. That should be correct. So the double bond is somewhere there, monomer from which this polymer is made. So this is 1 2 pent 2N, because this is carbon 1, carbon 2, this is 3, this is 4 5, so this is 2 and pent 2N. So I will go with option C. Last question, a little important. Number 40, the infrared spectrum is given to us, right? And the table is given, right? And we see that which functional group could be compound, which functional group could the compound contain. So we can see a peak there, a peak there. As per our table, the peak over this point, this is an ester, and also at this point, this is an ester. Let me show. So one is this one right here, and the other one is this one right here, ester over here, ester. So I will go with option C. So yeah, that is the question number 40. So I hope that was helpful, guys. That is the entire paper, and please leave comment on any question where there was a confusion, and I would definitely want to reply to those comments as soon as possible. Thank you. Peace.